Two coding models. One costs $25 a million output tokens and lives behind an API you can never open. The other is free to download, beats it on real benchmarks, and a trick that shipped this month makes it run 3 times faster. This is Kimi K3 from a lab called Moonshot AI. Hand it a broken front end and it rebuilds it. The same league as Claude Opus, and on blind developer voting it actually beats it, except the weights are public. You can run this one yourself. Then came the part nobody expected. A lab called Inferact bolted a trick called DSpark onto Kimi K3, and on a single request, it jumps from 118 tokens a second to 370. Watch the tokens fly. And here's the wild part. The output is byte-identical. Not similar. Identical. Same weights, same answer, same every character, just far fewer trips through the GPU. No retraining, no fine-tune, no quality tax. Start with the model itself. On the Artificial Analysis Intelligence Index, Kimi K3 scores 57. Claude Opus 4.8 scores 56. That gap is 1 point. On the front-end code arena, a blind developer vote where no one knows which model they are rating, K3 entered at number 1 with an ELO of 1,679. Claude Fable 5 was second at 1,631. The older Kimi K2.6 was sitting at number 18. On Frontier's WE, it posts 81.2. On Terminal Bench 2.1, it posts 88.3. On SWE Marathon, it scores 42.0 and leads the field. This is not a toy. Now the money. Claude Opus 4.8 runs about $25 per million output tokens. Kimi K3 runs at $15. And per completed task, the real cost of a hard job, Artificial Analysis puts K3 at about 94 cents against Opus, 4.8 at $1.80, roughly half the bill. And the weights ship on Hugging Face under a modified MIT license. The leader undercut for half price and left the door open, so the model is strong and it is cheaper. DSpark is what makes it fast. And these two belong together in a way that matters. 3 parts. First, why Kimi K3 is a genuine Claude beater. Second, how DSpark actually squeezes out that 3 times speed up. Third, the honest catch, because there is always a catch. Let us get into it. Kimi K3 is a mixture of experts model, 2.8 trillion parameters in total. But for any single token, only 16 of its 896 experts actually fire. That is 104 billion active parameters per forward pass, from a pool nearly 3 times the size of DeepSeek V4 Pro. Picture a firm with almost 1,000 specialists, and every meeting only pulls in the exact 16 who know the answer. Full knowledge, a fraction of the work. It holds a full million tokens of context. An entire codebase, every file, every test, every comment in mind at once. It pulls that off with Kimi Delta Attention, a hybrid of linear and full attention that Moonshot says delivers 6.3 times faster decoding at million token context compared to standard quadratic attention. And it ships with native vision, not a bolted-on adapter. Native. It reads images, screenshots, and video as part of the same model. Line the scores up. Artificial Analysis Intelligence Index, 57, 1 point ahead of Opus 4.8. Front-end code arena, first place, ahead of Fable 5, GPT 5.6 Sol, and everyone else. Is WE Marathon, 42.0, leading the field by 7 points. Frontier SWE, 81.2. For an open model, this was not supposed to happen yet. Watch it work. Point Claude code at Kimi K3. Hand it a failing test suite, and it reads the stack trace, edits files across the repo, and turns the whole suite green. The same agent loop you would run with Opus on weights you own. Here's the same job priced 2 ways. Claude Opus, 4.8, $25 a million output tokens. Kimi K3, $15. Same task, nearly half the bill per run, and you are allowed to read every last weight. Because it ships on Hugging Face, the copy you pull keeps working forever. No waitlist, no per seat fee, no terms that can be revoked overnight. If Moonshot vanished tomorrow, your local copy never stops running, and you do not need a new tool. Claude Code, Cursor, Klein, any agent that speaks the OpenAI API format. Point its base URL at Kimi K3 instead. Keep the harness you already know. Swap the brain underneath. The agent never notices the difference. So why is Kimi K3, or any large model, slow? Because it writes 1 token at a time. To produce a single word, It runs the entire network, gets one token back, then does it all over again for the next. Every word is a full round trip. Speculative decoding breaks that rule. A small, fast draft model sprints ahead and guesses the next several tokens. Then the big model checks all those guesses in one pass. The right ones are kept for free. It is spell check for the future. But classic speculative decoding has a weakness. The draft is dumb, so the big model rejects a lot of guesses, and every rejected guess is wasted work. Push too hard and you actually slow down. How big is the win with DSpark? Really? On Kimi K3 and vllm, with DSpark enabled, throughput goes from 118 tokens per second to 370. That is a 3.14 times improvement on a single request, measured on NVIDIA GB300 hardware. On coding and other low entropy tasks, the draft model gets accepted about 4.73 tokens per step. On creative writing and other high entropy tasks, it drops to around 2.61. The win scales with how predictable the work is. Code is predictable. DSpark rewards that. DSpark attacks the bottleneck from 3 angles at once. A block diffusion backbone drafts 7 tokens in a single parallel pass, not one by one. A lightweight Markov head stitches those tokens together so they read like a real sentence, not a random bag. And a confidence head scores how likely each guessed token is to survive, so the engine only bothers verifying the ones worth checking. It literally decides what not to verify. Skip the sure things, spend the compute where it counts. And remember, none of this changes the answer. The verification step guarantees the output is exactly what the model would have written token by token. You are not trading quality for speed. You are getting the speed for free. Here's why these two belong together. Inferact built the Kimi K3 DSpark draft model to mirror K3's own MLA attention design, which means the draft and the target share 1 KV cache layout. That is a compact 576 element latent per token. So KV offloading and pre-fill decode disaggregation work without any separate page format. The draft was trained on hidden states extracted from vllm itself, the same engine that serves it. So the numerics it learns from are the numerics it meets at inference. 1 afternoon of compute to train the drafter. Then the speedup is yours to keep. The on-ramp is short. The weights land on Hugging Face. vllm loads the mixture of experts natively, with full day 0 support, and the DSpark drafter clips on top with a single flag in the serve command. Open model, open server, open speedup. Not a single piece of the stack locked behind a login. So here's the full picture. Download Kimi K3. Attach the DSpark drafter from Inferact. Run the world's largest open weight model at over 3 times the base speed on hardware you control, with no API bill and no rate limit. The model already trades blows with Opus. DSpark makes it fly. Step back and the pattern is obvious. One open lab shipped a model that matches the best closed ones. A second team shipped a speedup that triples throughput without touching the weights. The frontier used to be a private garden. It is starting to look a lot more like a public library. Now the honest part. That 3.14 times speedup is the ceiling on a single clean request, not the promise on a busy server. For coding and structured tasks, DSpark performs best. For open-ended creative work, the acceptance rate drops and the gain shrinks toward 2 tokens per step instead of 4. You also need the DSpark draft checkpoint trained specifically for Kimi K3. Use the wrong drafter and the acceptance rate collapses. A bad guesser just piles on overhead. Then there is the elephant. It is still a 2.8 trillion parameter model. Serving it requires serious memory. The checkpoint in native MXFP4 format comes in at about 1.5 terabytes. The official vllm recipe requires at minimum an 8 GPU Blackwell node. Free to download is not free to run. And on factual questions, artificial analysis measured K3's hallucination rate at 51%, up from 39% on its predecessor. It gets more things right overall, but it also confidently gets more things wrong. For code generation and agentic tasks, that trade-off is often fine. For anything where a wrong, confident answer is worse than an honest abstention, verify the output. 4 numbers to keep, 2.8 trillion parameters, 104 billion active. 1 point ahead of Opus 4.8 on the intelligence index, half the cost per task, and 3.14 times faster for byte-identical output. The takeaway is simple. The best models are no longer only the closed ones, and the fastest tricks no longer live only inside the biggest labs. Kimi K3 proved open can compete. DSpark proved open can be quick. Together, they proved you can have both. So here's the real question. If a free model can match the best, and a free trick can make it fly, What exactly are you still paying for? That is the one to sit with.